Today we're looking at compound inequalities. And these are just like our other inequalities, except they're sort of either joined together. They're compound, there's more than one of them. Compound inequalities are two inequalities joined by the word and or by the word or. Inequalities joined by the word and are called conjunctions. So they are joined together, they include the numbers between each one of them. Inequalities joined by the word or are disjunctions. So they're kind of separated. One is going one way and the other one is going the other way. They don't include the numbers between them. They include the numbers that are going the opposite directions, which we'll see in just a second. You can represent compound inequalities by using words, symbols, or graph. Complete a table. The first two rows have been done for you. So let's see. All numbers from 3 to 8 inclusive. So this includes all the numbers from between 3 to 8. It includes 3 and 8 because that's the inclusive part. And these could be 3.5, it could be 4, 4 and a third, anything like that. It's anything that's between 3 and 8. The inequalities would look like this. It has to be greater than or equal to 3, getting bigger from 3, and less than or equal to 8, smaller than 8. And we look at our picture of our graph, and you can see that it uses these solid colored dots to include 3 and 8 in the shaded part. And it's more than 3, but less than 8. That is one that you use the word and on the two inequalities. The second one, all numbers less than 5 or greater than 10. So that -2, 0, 3, all of these choices, you would write that as less than 5, x is less than 5, or greater than 10. We use the word or because they do not cover the same numbers. And you can see that in the graph where they use open circles on the numbers because you're not including those. It is either less than it, but it is not 5. So 4, -100, something like that, it would go to the left on the number line. Greater than 10 would be 11, 12, 1000, anything greater than 10. The numbers between them are not included. Let's look at the third one on this for us. All numbers greater than -1, so that could be -0.8. That could be 0. And it's got to be less than or equal to 4, which is including 4 on that one. Or it could be 3 or 2.000000005. The way we would write these inequalities, all numbers greater than -1, not including -1, so it'd be x is greater than -1, and less than or equal to 4. X would be this right here, copy and paste. Less than or equal to -4. Oops, sorry, +4. Now we need to put in the graph, and this is a little tricky, so I'm just going to use the marker tool to kind of draw it in. Well, if you have your book, you'll be able to draw it in with your pencil, but on the computer, slightly trickier. There are ways to do it, but I'm not wanting to get into that right now. And pretend that this is a straight line, and that I could draw any kind of way with a mouse. Alright, let's have -1. I'm going to circle it because we're not including it. 0. I don't know why I put it on top and when I was doing these on bottom. 1, 2, 3, 4. Now 4 is included this time, so it will be a shaded in circle. and the lines will be shaded in between them. So that will include all the numbers between -1 and 4. All right. Next, all numbers less than or equal to 3. So less than or equal to 3. It includes 3. It could be 2. It could be -5. Anything less than or equal to 3 or greater than 6. So not including 6, but greater than 6. 6.7, that'd be fine. 700, that's fine. We would put those, let's see, less than or equal to 3. X is, copy this again, less than or equal to 3, or X is greater than 6. Do it like that. All right, number line again. Rough drawing. We have, let's say 7, 6, 5, 4, 3. Okay. Greater than or equal to, less than or equal to 3. Closed circle, so shaded in circle, and everything less than 3 is towards this way, infinity. So that includes like 2 and 1 and all the numbers going this way. Just pretend my graphs look like these up here, please. And greater than 6. This is an open circle, and it covers the numbers to infinity going greater, getting bigger. Okay? So, compound inequalities. There's more than one inequality, and on the graphs, they can go different directions, or they can include the ones in between. All right. Use the graph organizer below to compare and contrast the graphs for conjunctions and disjunctions. All right. We just need to enter in a couple of different words for the similarities. They're similar in that, let's think, similarities between conjunctions and disjunctions. Well, they both are inequalities. They're not equations, they're inequalities. Okay. They both cover a range of numbers. And let's say what some differences are between conjunctions and disjunctions. Let's see, conjunctions meet while disjunctions don't meet, don't touch. Okay, the conjunctions will join together, the disjunctions will grow apart. Okay, let's see the example that they give us. Spartan Middle School distributes this chart to students each year to show that students must be able to do what they must be able to do to pass the fitness test. So, if this is your age, 12 or 13, you have to run the mile. And if you're a boy, you need to run an 8-minute mile to 10 minutes and 30 seconds if you're 12, or 7 minutes, 30 seconds to 10 minutes if you're 13. So I guess they expect you to get faster the older you get. And girls would need to run the mile in 9 minutes to 12 minutes for both 12 and 13. Push-ups, boys should be able to do 10 to 20 when they're 12 years old, or 12 to 25 when they're 13, and girls can do 7 to 15 on both of their ages. Modified pull-ups, boys can do 7 to 20, should be able to do, not can do. To pass the test, they should be able to do 7 to 20 modified pull-ups, or 8 to 22 when they're 13, and girls 4 to 13 on both of their ages. So we need to write in the compound inequality that describes the push-up range for 12-year-old boys. So really, right here, this little section is what we need to do. So let's choose a variable. P for push-ups, that's okay. P push-ups start with P. Determine the range and write the inequality. All right, well, here's the thing. Here's the range, 10 to 20. So it has to be greater than 10 or equal to 10, greater than or equal to 10, and less than or equal to 20. So here we go. Greater than or equal to 10, or less than or equal to 20. Now look at this. When you have compound inequalities that are inclusive like this, you can join them together even more than just writing p greater than 10 equal to 10 and p less than or equal to 20. Since it's right in the middle, you can actually put that right here in the middle. So it still says the same thing. P is greater than, when you read it this way, or less equal to, P is greater than or equal to 10, which is the same thing as saying 10 is less than or equal to P, and P is less than or equal to 20, which was our normal one. So we can kind of flip this one around so that it's joined in the middle, joined at the hip, so to speak. And then we have our graph, and you'll notice that it is intervals and not covering the middle parts, because when you're doing a push-up, you either did one or you didn't. So you can't really cover, say, 14 and a half push-ups. You did 14 push-ups or you did 15. You don't really do half of push-ups. So make sure you understand the problem, what it's talking about when you're doing your graphs and things. Sometimes you can cover in between. Like if it was talking about dollars or something, you could like have 14 and a half dollars, but you wouldn't be able to have 14 and a half push-ups. You either did 14 or you didn't. All right. Looking over here just to make sure the inequality P is greater than 10 is equivalent to the inequality 10 is less than or equal to P. That's how we could flip it around. And so that was also the way that we can write these things in a more fanciful way, sort of. It looks a little bit better writing it like this than writing this whole thing right here. I mean, you save like a word and maybe a letter. It adds up if you do a lot of them. Okay. In upper level mathematics classes, inequalities are expressed in the interval notation. So you don't really need the less than or greater than signs anymore if in the upper level classes, because you can use parentheses as greater than or less than. You just say this goes from 3 to infinity. And if you're using the less than or equal to or greater than or equal to, you would use brackets. But again, that's for later on in your math, not right now. All right, let's try these. Write and graph a compound inequality for each range or score. The push-ups range for 13-year-old boys. 13-year-old boys, push-ups 12 to 25, inclusive. So I would write 12 is less than or equal to 25. Actually, I don't need to do that color. 12, you can use this button right here. And it should have the less than or equal to sign right there. 12 is less than or equal to whatever push-ups, P. Let's use a different letter because push-ups and pull-ups could be the same thing. Let's just say L. Just, no, that looks like an I or something. We'll do K. All right, which is less than or equal to, I remember to use that button. I've already forgotten what I was saying. 12, 25. Now this is covering my button to. Hold on just a second. Still covering it. I can't click out of this because of that thing right there. Alright, hold on just a second. I'll just copy and paste that, and let's hope it stays like that. Nope, shouldn't have done that. Alright, hold on just a second. I'm going to get it 12. Copy and paste is less than or equal to, what do we say, k, which was less than or equal to 25. Okay, now we also have to graph that. So instead of drawing, I'm going to go over here to the Desmos calculator graphing. I'm going to go and say 12 is less than or equal to x, which is less than or equal to 25. Zoom out a little bit and let's see if I can move over right there. 12 to 25 covered inclusively. And we'll save that, and there we go. It draws it for us. I guess if I write it, I don't need to write it there. I can just put it in this Desmos calculator. I'll do that next time. Let me just delete this one in. We don't need k. All right. The pull-up range for 13-year-old girls. Desmos calculator. We'll just do it this way. Pull-up range. Okay, let's go up here. Pull-ups. Girls. What age did they say? I'm very forgetful. 13. 4 to 13. Okay. It was the same for both, so I didn't really need to be that forgetful. 4 is less than or equal to x, which is less than, not greater than, less than or equal to 13. Okay, inclusive, yes. Save that. Got it. You can zoom in a little bit if you need to see it a little closer. All right. So you see how to do this, I hope, that you can just put it into this little Desmos calculator and it'll graph it for you. But really, you should be able to do this without a graph calculator. It's a little hard to draw on this computer. But this is how you make it. Make sure you understand that part, that it is between 4 and 13, and it includes those numbers. And that's why we use the less than or equal to signs over here. Okay, let's look at E. We'll skip these two since they're more similar. We just put in the ranges and graph them. A score outside the healthy fitness range zone for girls push-ups. All right, outside of the push-ups for girls, 7 to 15. So it would have to be now it's not letting me click. Let me make sure. Try that one more time. Hold on. I guess we're just going to list that score outside there. So 7 to 15 is what's included. Anything outside that would be fine. I mean, 100 would be outside that. Or 5 would be outside that. Okay? The score outside of those. That's what we want. But we want to write and graph the inequality for those. So let's come in here and say it has to be x is less than 7 or x is greater than, what was it, 15? Yeah, 15. And now it's going to let me do it. It figures x is less than 5, no, 7, I'm sorry. And x is greater than 15. And you see here how it includes the 2 right there. All right, let's save that. Let's delete this mess. Okay, let's see. Why are individual points used in the graph? See, I talked about that a while ago. Again, not reading ahead on my own lessons. Why are you individual points? Well, say you can't do partial, or not you can't do, we'll just say partial push-ups. Partial pull-ups and push-ups don't count. All right, the solution of a conjunction will be the solutions that are common to both parts. Now remember, we've just been graphing the inequalities so far. We haven't actually solved any. So let's look at this, solving them. Break the compound inequality into 2 parts. Well, here's our compound inequality. You have it's between 3 and 8. 3x minus 6 is between 3 and 8. And to solve this, we need to do this part. Okay, we're going to solve this part. And we're going to solve this part. Okay? Don't like put 3x goes on this side and minus 6 goes with this side. No, it's the whole thing in the middle. You solve it with the left, and then the whole thing in the middle, solve it with the right. So it's 2 problems in one. That's part of the compound thing. It's more than one problem. So we solve 3x minus 6 is greater than 3, or 3 is less than 3x minus 6, however you want to say it. We would need to get rid of the minus 6 part first by adding it to both sides. Okay, we get 9 and 3x is less than 3x. We need to divide both sides by 3 to get rid of this part. And you get 3 is less than x, or you could say x is greater than 3. Either one of those is fine. And you have your graph right here to show you that. Again, solving using the same steps, the same properties of equality as we did in equations. We still need all of that now, solving inequalities. Solve and graph 3x minus 6 for less than 8. And here we go, add 6 to both sides again, divide by 3, and you get 4 and 2/3. And you come about 4 and 2/3, and it's less than. You see both these are open circles for the less than and greater than signs. And it's this way. Determine what is common to the solutions of each part in the inequalities and graph in steps 2 and 3, and the points between 4 and 2/3 and 3 are in common. So this was greater than 3, see, greater than 3, but less than 4 and 2/3. And so when we put these two graphs to the middle, and to put these two graphs together, they sort of meet in the middle. We don't count the things outside of the ranges here, because it's got to fit both conditions. It's got to be greater than 3, but also less than 4 and 2/3. So there you go. You've joined your graphs. You made a compound graph of a compound inequality. So let's look at part A on these. Solve and graph each conjunction. And remember, we're going to break it down into 2 parts. We're going to have -1 is less than 3x plus 5. We're also going to have 3x plus 5 is less than 6. We'll solve both of these. The first one, I will need to subtract 5 from both sides. Get rid of this part, plus 5. And that will leave me with negative 6 is less than 3x. And then I will need to divide both sides by 6. So negative 6 divided by 6. No, sorry. 3. Divide both sides by 3. Then 3x divided by 3. And that gives me negative 6 divided by 3 is negative 2. That's less than 3 divided by 3 is x. This one, same steps. 3x plus 5 minus 5 is less than 6 minus 5. 3x is less than 6 minus 5 is 1. Divide both sides by 3. 3x divided by 3 is less than 1 divided by 3. And that is x is less than 1/3. Okay? Now that we've solved them, we will put this into our graphs. And on this program, you can do this by saying that. Let's see. Negative 2 is less than x. And x is greater than 1/3. Trying to see if there's a fraction button over here. We'll just put 1 divided by 3. Actually, this one is less than. I was wondering what was. So, we can actually put these on the same line to make it look better. There we go. Now it looks cleaner. It includes both graphs in between, negative 2 and 1/3. And there we go. We solved the inequalities, broke it into 2 pieces. Okay, this piece and this piece. Solved it, we got this. We graphed it. Let's try one more. Let's do D. Break it down into our 2 pieces. 3 times x plus 6. And 3 times x plus 6 is less than 18. All right. So let's see. This first step, I would need to distribute. So 3x is less than 3x plus 18. And then we'll bring it to the other side by subtracting 18 from both sides. That'll be negative 20 when I subtract 18 from both sides and get is less than 3x. And then divide both sides by 3, and you'll get negative 20 divided by 3 is less than x. Over here, similar steps, 3x plus 18, just using distributive property. Okay, subtract 18 from both sides, and you get 3x is less than 0. 18 minus 18, and subtract 18 from both sides. And then divide both sides by 3, and you get x is less than 0. 0 divided by 3 is 0. So we have it's less than negative 20 thirds and less than 0. Did I ever fix this one up here? Yeah. Calculator, put it together. Let's see, negative 20 thirds less than x, which is less than 0. And there we go. Here to here. Remember, negative 20 thirds, that's 3 goes in 26 times with 2 left over. 6 and 2/3. See, almost a 7 when you zoom in. Just showing you that the calculator's doing it the way you would think it would. And there we go. All right. The solution of a disjunction will be all the solutions from both its parts. So, same concept. You have to solve both of them. This disjunction and this disjunction. We solve each one of them. And you can see this. Add 3 to both sides to get rid of it. Divide by 2. Here's your graph. Add 4 to both sides. Divide by 4. Here's your graph. Put the two graphs together, and there you go. Okay? So let's keep going. The solutions of a conjunction or graph below. What is the inequality? Okay? Looking at the picture and seeing what it says, it is greater than 0. You know it's greater because it's open circle. It's not greater than or equal to. So 0 is less than x. Remember, greater than x is greater than 0, or 0 is less than x. Same thing. And then it is also less than or equal to 5 because it's got the dark circle. So less than or equal to 5. I just copied and pasted that less than or equal to sign, but you could have used this button right here to enter it in. There you go. Just by reading this, you can tell what inequality it says. Okay, so practice the rest of the problems that we didn't do together on your own. Just think about how we just solved some inequalities using the same step that we were solving equations, and we learned how to put our inequalities together for conjunctions or together instead with disjunctions. Disjunction. Let's find a picture they drew. It looks pretty. Conjunction. Okay. All right.